Pupils at Bishop Ramsay School in Hillingdon are about to meet Dr. Ken Farker. He's a scientist, but not like any scientist they've met before.
I started off as a scientist at the University of East Anglia studying chemistry. More importantly, it was soap bubble chemistry, and most people don't actually take me seriously when I say I'm a soap bubble-ologist. In my spare time I was a juggler, and somehow I've managed to combine the two together. All right, we're going to look at the science of circus skills and all the different things to do with circus skills. Let's get you warmed up first of all.
Ken's performing a workshop at the school as part of a fortnight of enrichment activities for Year 9.
Shout out the words, please. That's very good. If you shout it rather than say it, it'd be much better. Shout out the colours.
Red, green, blue.
Basically, in this show, you're going to be finding out why tightrope walkers keep moving to stay balanced and why jugglers love gravity. Right, I'm going to do a quick memory test. I'm going to do a few juggling tricks. I want to see how many you can remember. This is 3 in 1 hand pose. Often forgotten. 3 behind the back. Often unappreciated. This is called the cascade. This is the outside cascade. This is 1 high. This is called kissing. I wonder what's going to happen now. French kissing. Under the leg, under the other leg, behind the back, behind the other back, behind both backs. In the show, I'm using all the techniques that I've learned as an entertainer. If I was doing street theatre, it would be to win the crowds over. So you've got to do something spectacular, first of all. This is the Japanese robot. Yeah, 6 months, no social life for that one, right. And then once you've actually engaged your crowd and you've won them over and they actually want to listen to you, you can then start introducing the science. And we got the finish. How does it go up? Because I apply a force to make it go up and then gravity makes it go down. So I apply a force, gravity pulls it down, apply a force, gravity pulls it down, apply a force, gravity pulls it down. Or you can do it from here, you can do it from here, and alternatively you could do it from there. I got interested in communicating science because it was compulsory in my PhD to actually describe what I did. It was compulsory for everyone else, and I had to listen to every other PhD student's thesis. Unfortunately, I very rarely understood what they were talking about. And I thought, if I can't understand it, and I'm a PhD student, my mum's not going to understand it. Look at that, the spitting resemblance of Galileo. Now, they used to do experiments from this tower, the Leaning Tower of Pisa, and a big crowd would just come in, just like this, and they used to throw things off the tower. And one day someone said, I know what, I'll get them out. I'm going to give them my sock. Can someone please just give me a sock? I also saw all these other people who were entertaining, and it was a form of communication through entertainment. They were engaging the audience, and I thought if I could engage an audience through entertainment, then surely it's a simple process of putting science in. So now, the experiment we're going to do is we're going to drop both objects from exactly the same height off the tower and see which one falls the fastest. Prediction, how many people think the heavy sock will fall fastest? How many people think the lighter ball will fall fastest? And how many people here want to phone a friend?
We're hoping that children will see that both science and maths can be fun.
Right, drum roll please.
And that it's not just all about learning facts and figures and doing sums in the classroom. And that there are many, many facets in life where science and maths are important, and it can lead on to all sorts of different things as well.
It's roughly the same speed, and it just goes to prove it doesn't matter how smelly an object is, they will still fall at the same speed. So it also doesn't matter how heavy an object is, it will fall at the same speed. But if I give you a different object, if I rip this out of my book, and we do that. If you like to drop those at the same time, please, from the same height. Hang on a second. What force pulls things down? Is gravity present here? It's lighter. Yeah, but lighter doesn't make any difference. It's because I've got wind. Has he got wind? No, that was the sock. Okay, you're right. It's air resistance. And you need air resistance because without it, as a parachutist, you'd only do it once. Well, Galileo, it's been fun yet again doing experiments with you. Could you please give David a big round of applause?
After a while presenting his shows and workshops in schools, Ken decided to qualify and work as a teacher.
I went into teaching because I wanted to see the two sides of the classroom, one from the teacher's perspective and also from the pupil's perspective. Do you feel your finger getting hotter? Yes. That's great, isn't it? You must love this one when Ofsted are here. Oh, yes. As a science communicator, I went into schools once and then I left and I wouldn't see them again. So I wouldn't see what they had done to get to that point and what happened afterwards. And I was really interested to see how I could improve my show so it dovetailed into the curriculum. So I felt that by becoming a teacher and experiencing the problems a teacher has and the goods, the highs, the lows, I thought I could actually improve what I did. What I use here, Lucy, is motivation. No, actually, we're going to apply the friction to the bottom of the ball using this drill, and then the friction will go onto the ball and hopefully keep it spinning. With me so far. So I'm going to give you this drill. Go. Of course, we do have one fundamental problem because gravity at this moment is pulling down, which is the weight of the ball. The drill is still behaving like a drill, drilling into the bottom of the ball. So in other words, at some point, this may go bang. But it's okay. It's okay. I'm at a safe distance now. Bang! Lucy!
Although he's a qualified teacher, Ken has returned full-time to developing his shows, which he adapts to address different age groups and topics.
This is really good.
Some of his workshops give pupils hands-on experience of physical theatre skills. The effects on pupils who try to learn them are of particular interest to him.
A number of people do taster workshops in schools, and I was a bit concerned that there were a number of claims that by merely doing circus skills, walking a tightrope, learning to juggle, that you will improve discipline and motivation within the classroom. And I didn't see any evidence, any studies that would vindicate this.
Ken worked with Martin Sawyer at the City of Norwich School to study how the learning process would affect a group of Year 8 pupils with poor non-verbal reasoning skills. 2 cohorts took part in a 5-week intervention in which they tried activities like juggling and devil sticks. Ken and Martin thought the pupils would find the activities exciting, even if they were hard to master.
It didn't turn out as we expected. After one of the first sessions, we noticed that students began reacting to the new and novel and exciting learning experience we were giving them in the same way they started reacting to many lessons. They were disengaging and the children were focusing in a very negative way. I can't do this, obviously with much more colourful language, or they would say this is rubbish, you know, we don't want to do it, and there was that sense of failure.
With the second cohort, Martin and Ken changed their methods.
We used something very similar to solution-focused brief therapy, which is where you engage the students very much in the whole activity, getting them to plan what they're going to do next as a result of their past experience, and where they were successful, what was the difference? When you were successful, how did it feel?
Pupils were encouraged to focus on small, achievable steps and to analyse successful techniques so they could be applied elsewhere.
We found with the second cohort they achieved a great deal more than the first cohort in actually not just the learning tasks, but we had tested the students with non-verbal reasoning tests before and after, and we found the second cohort scored much better. They'd made, I would say, significant improvements on the tests because they had the confidence.
Lessons learned about engagement during the study were considered important and subsequently applied elsewhere in the school.
So, apply a force on one side. Are you left or right-handed?
Back at Bishop Ramsey, the pupils are getting to grips with unfamiliar skills.
Okay. Look at it. Okay, move round, move round. There you go.
Over the course of a day, Ken has worked with 180 pupils. So what's the feedback?
It was really good, like the gyroscopic force used in the plate spinning and all the examples we were given of the forces, like when you drop things and gravity's used in the juggling, and when you drop paper it's more slow because of the air resistance.
Well, I was surprised by the amount of science that was actually put into it. You didn't actually think it was science, you just thought it was fun and you were just going along with it. And I don't think you realised how much you were taking in. And when you come to use it later on, you'll realise how much you've actually learned.
From a teacher's point of view, it was very successful indeed. We could certainly see the enthusiasm on the children's faces. Being out on duty at lunchtime, for example, today, they were all talking about it. One of the science teachers came in and was observing this afternoon when I was, and she was certainly saying, well, I could do that in my lesson. Well, that's good. Well, I hadn't thought of that before.
It's the kind of reaction Ken values.
Let's have a quick debrief. So, I think there's always a role for creative practitioners in learning. It's how you use them. I don't think they're a substitute for learning. I think partnership is the big word. Sometimes teachers and members of the public who have seen my show are extremely enthusiastic at what I do, and they believe all teachers maybe should be like me. I think that what I do is complementary, and that I think there's a lot of good science teachers out there, and I think they're doing a fantastic job, and that there is a role for people like myself to give a little lift in schools, and that people like myself should be used to do that.